Page 697, number 5. Rotate the axes to eliminate the xy term in the equation, then write the equation in standard form and graph. Well, before we rotate the axes, before we graph, let's first figure out what kind of shape this will be. We can take a look at the discriminant at b squared minus 4ac, and that'll tell us what kind of shape we have. Well, b is the number in front of the xy term, so b squared is negative 4 squared, or 16, minus 4 times a times c, which are both equal to 1. So 16 minus 4 is 12, which is greater than 0. Since it's greater than 0, we know we're talking about a hyperbola. So in the end, we're going to have the graph of a hyperbola. Now that we know what shape we're dealing with, let's talk about the angle of rotation. We have a formula that says the cotangent of 2 theta is equal to a minus c over b. Well, a and c are both equal to 1. B is negative 4, so this is going to be 1 minus 1, or 0, over negative 4. Well, the cotangent of 2 theta equals 0 over negative 4. That means if I tried to sketch this, cotangent, well, tangent is opposite over adjacent. Cotangent is adjacent over opposite. Well, the only way to possibly sketch a triangle so that this adjacent side is 0 is if this segment were to go straight up and down. So that means 2 theta equals 90 degrees, which also means that theta must be equal to 45 degrees. So we have a rotation of 45 degrees. Okay, now that we know the shape, now that we know the rotation, now we can eliminate the xy term in this equation. Well, we have two basic equations that will help us do this, and they're both based on the sine and cosine of this angle measure, 45 degrees. So those two equations, I'll write them down. One of them is x equals x prime times the cosine of theta, which in this case is 45 degrees, minus y prime times the sine of theta, which is 45 degrees. The other equation is y equals, looks very similar, x prime times the sine of 45 degrees plus y prime times the cosine of 45 degrees. Now I can look on my unit circle to find the sine and cosine of 45 degrees. They're both equal to the square root of 2 over 2. So x is going to be equal to the square root of 2 over 2 times x prime minus the square root of 2 over 2 times y prime. Y is going to be equal to the square root of 2 over 2 times x prime plus the square root of 2 over 2 times y prime. So now we need to make some substitutions. Anywhere we see an x in our original problem, we're going to plug in this new value of x. Anywhere we see a y in our original equation, we're going to plug in this new value of y. So let's make those substitutions. So instead of writing x squared, we're going to write the square root of 2 over 2 x prime minus the square root of 2 over 2 y prime quantity squared. Minus, instead of writing 4 times x times y, we're going to write 4 times my new x, which is the square root of 2 over 2 x prime, minus the square root of 2 over 2 y prime, times my new y, which is the square root of 2 over 2 x prime, plus the square root of 2 over 2 y prime. Plus, instead of writing y squared, we're going to put in our new y and square that value. The square root of 2 over 2 x prime plus the square root of 2 over 2 y prime quantity squared plus 1 equals 0. So we have rewritten this original equation, but we're substituting this anytime we see an x and this anytime we see a y. Okay, what we've got here looks messy, but let's try to simplify. First, we need to square what's in parentheses right here. So I can write that out twice, multiply using FOIL. When I do that, I will get 2/4 x prime squared, which we can write that as 1/2 if we choose. I'll leave it 2/4 for now. Then I will get minus 2/4 x prime y prime minus another 2/4 x prime y prime, which would give me minus 1 x prime y prime plus 2/4 y prime squared. Okay, that's this first set of terms squared. minus 4 times. Now let's use FOIL to figure out what we get when I multiply these two. Now if I multiply the first, I'll get 2 fourths x prime squared. My outer and my inner terms will cancel out. That's a good thing. And last, I'll get minus 2 fourths y prime squared plus. Now, for this last set of parentheses, we can write it out twice, multiply using FOIL. If we do that, we get, let's get rid of that parentheses. We get 2 fourths x prime squared plus I'll get 2 fourths x prime y prime plus another 2 fourths, which equals 1 x prime y prime plus 2 fourths y prime squared plus 1 will just come down and it equals 0. Okay, let's try to combine what we have. So I'm going to underline all my x prime squareds. So I have 2 fourths x prime squared. Right here I have minus 4 times 2 fourths x prime squared. Here I have another 2 fourths x prime squared. So I have this is equal to 1 half. This is negative 2. This is another 1 half. So 1 half plus 1 half is 1 minus 2 is going to give me minus 1 x prime squared. Now let's combine the x prime y primes. I have an x prime y prime right here. I have another one here. Those cancel out. That's perfect. That's what we want to happen. Now my y prime squared. I have 1 half y prime squared right here. I have negative 2 times negative 1 half y prime squared. And I have another 1 half y prime squared. So I have 1 half plus 1 half, which is 1. Here I have negative 4 times negative 2 fourths, which is positive 2. So I have 1 plus 2. So we have plus 3 y prime squared. And then this plus 1, let's move to the right-hand side, say that equals negative 1. Well, now let's divide everything by negative 1, which will give us x prime squared over 1 minus 3y prime squared over 1 equals 1. And if I multiply top and bottom here by 1/3, that'll give me 1 y prime squared over 1/3 in my denominator. So there's my standard form of this ellipse. Okay, let's squeeze a graph of this down here. This ellipse is centered at the origin, and it's rotated 45 degrees. So if I make a new set of axes, I'm going to rotate 45 degrees. So here's x prime, here's y prime. I know that this ellipse has a stretch of 1 in the x direction, and it has a stretch of the square root of 1/3 in the y direction. Well, square root of 1/3, we'll put about here. So if I make a box and some asymptotes, I know that this ellipse, since the x's come first, now in this case the x primes will come first, will look something like this. Or excuse me, this hyperbola will look something like this. So here's a graph of my hyperbola. So there's a graph of this function. We've rotated the axes. We got the equation of a hyperbola, which we expected, rotated 45 degrees, and there's the graph of this function, of this equation, excuse me.